All right, just going to do a quick follow-up to the greatest common factor factoring as we begin our next couple weeks of factoring. This is the first kind of factoring and it's the most basic, but it can take a little while to get used to. So what I really want you guys to remember is to think about this as undistributing or reverse distributing, okay? Normally when we distribute, we're multiplying whatever's on the outside of the parentheses by everything in the parentheses. We make sure that that all gets done. But now we're going to take something that's all multiplied together and we're going to pull it back apart. All right. So what I'm looking for here, the key, is to look for what factors do they have in common. And remember, factors are just anything that's connected with multiplication. So let's just refresh here. I have a 10 and a 35. So I'm just going to start with the numbers first. What number divides into both of those? So what factors do they have in common? Well, into 10 you have 1, 2, 5, and 10. Into 35 you have 1, 5, 7, and 35. Well, the greatest common factor, they both have 1 in common, but the greatest common factor is 5, right? So that's where I'm going to start, is by, oops, let's see if I can get rid of all this. There we go. Is by factoring out of 5. And then I look to the x's next. So x to the 7th, so I have 7 x's multiplied together here. I have 6 of them multiplied together here, so I can take out 6. They have 6 in common. You're always taking out the lowest amount of the variable that they both share. And then next up we have y to the 5th. Over here there are no y's though. So they actually don't have any in common, and since I'm looking for the greatest common factor, that means I can't remove any y's. So then I'm going to start my parentheses, and now I'm doing 10x to the 7th, y to the 5th, divided by 5x to the 6th by my greatest common factor. Well, 10 divided by 5 is 2. Oops. X to the 7th divided by x to the 6th. Remember, we subtract our exponents when we're dividing, so that's x to the 1st. And then y to the 5th, if there's no y's to divide it by, it's just going to be brought down as part of my answer. Now the plus sign will carry down, and then 35 divided by 5 would give me 7. X to the 6th divided by x to the 6th, since I took all of those x's out, there's nothing left there, right? So this is my factored answer. And remember, you can check if you're right by distributing 5x to the 6th back through. So 5x to the 6th times 2x to the 1st, y to the 5th would be 10. X to the 7th, y to the 5th, which, okay, yep, that part checks with the first term. And then 5x to the 6th times 7 is just 35x to the 6th. Okay, that checks with the second part. So you don't have to do this check step, but it's a good way to know if you got it right or wrong. So let's keep that in mind. We're looking for what's in common, what factors are in common for both terms. And let's look at one like this. So when you guys look at this, this is 3x times x plus 1 and negative 4 times x plus 1. Now I know that your inclination is going to be to distribute, but I want you to think about, we're trying to reverse the distribute. So if you distribute 3x into x plus 1 and negative 4 into x plus 1, that's going to give you a simplified answer. However, it's going to be the opposite direction that we actually want to go. So don't distribute when you see something like this. What we want to do is look for what factors do they have in common. Well, they both seem to have a factor of x plus 1 and another factor of x plus 1 over here. The whole thing is considered a factor because it's contained in parentheses. It's in the grouping symbol. So if that's what they have in common, then that is what I'm going to take out as my greatest common factor, right? So x plus 1, that's my GCF. And then in parentheses, we want to put down what would be left over. Well, if I take out x plus 1, all I would have left is 3x in the beginning. And all I would have left over here is -4. So we get two factors like this, x plus 1 and 3x minus 4. That would be my factored form here, okay? So you're looking for what factors do they have in common. Whatever's in common is going to be taken out as the greatest common factor. And then in the second set of parentheses is what would be left over, okay? Now we could multiply this all together and we would end up with the same expression if we wanted to check it. But I think we can rest assured that we're correct here, all right? So, and remember, the goal of all this factoring is when we start to go and graph parabolas in a little while, these parabolas, we find where they cross the x-axis by knowing these two factors, okay? So it's really important that we understand this factoring so that we can eventually help put that on the graph. All right, now I want you to pause the video and you try. See if you can come up with the factored form. So look at what they have in common of 2x times 6 minus 3x times 2x. See if you can factor that. So pause the video, factor, and then restart it, and we'll do it together. All right, so hopefully you figured out what the answer is going to be. So right now I want to look for what do they have in common. Well, I see 2x here and 2x here, right? This whole piece is a term. They're connected with multiplication, so that's one term, and this is the second. And they both have 2x in common, so that's what I'm going to take out as my greatest common factor. And then I put some parentheses down, and then what we have left over looks like a 6 and a minus 3x. So there is my factored form. Did you get the same answer? Hopefully. All right, so please log on now and try your next assignment, which is just focused on greatest common factor a little bit more. And remember, if there are assignments you haven't submitted yet from what we've been working on these remote school days, please get that stuff turned in. If you need help, find me on Zoom. You can just chat and send me some pictures of what you're working on. Or we can actually do a meet and I can write on the whiteboard part for you.